friend like me didn't realize that data and savings time started yesterday. Okay. Logarithms. Logarithm base b of a positive number x satisfies this definition. For x greater than 0, b greater than 0, and b not equal to 1, y equals log b of x if and only if b to the y equals x. This is saying that the logarithmic function is the inverse of the exponential function. So that is read logarithm base with base b of x, or simply log base b of x. Logarithm y is the exponent to which b must be raised to get x. What we're going to see here is, just like we did with the exponential function, graph of logarithmic function for several different bases, specifically base 2 to 20, the integers 2 to 20. Let's see what's happening. So again, we should notice as our base gets larger, should notice a few things. This isn't actually shrinking. What it's trying to show is that it just converges to that line quicker. And notice that this is now getting less steep. Right? So again, it's starting to converge to this line. Well, I don't want to say converging to that line because it's really not. Right? It appears to be converging to that line. right? Or the rate at which we're increasing decreases. And that's as our base gets larger.
Oh, we're talking about logs today?
And we're going to look at 1 over b. Again, we're going to let b just be integers from 2 to 20. Right? And you should notice a very similar pattern. In fact, what is the difference? Let's get that down to 2. Let's get that down to 2. All right, so what's the difference between log base b and log base 1 over b?
Is it reflected across the y?
Not the y.
I meant the x. My fault.
In this case, it's now a reflection across the x-axis, right? Again, as with the exponentials, let's just graph both on the same axis so we can very easily see the similarities. What is the one similarity you see, the one identical property you see in regards to the base?
The intersection?
What do you mean by intersection?
The x-intercept point?
What does it appear to be?
1.
In regards to the base, same x-intercept. Just like with the exponential function, same regards to the base, had the same y-intercept, which was 0, 1. What was the domain for the exponential function?
All our numbers.
What was the range?
It was like infinity to the y, or the y into asymptote or something like that. It was like it just went down.
So what was the range?
All not including 0 infinity, right?
Now use that information. What's the domain of the logarithmic function?
Not including not including 0 infinity.
Mm-hmm. What is the range?
All our numbers.
All the numbers. Again, using this information, do we have an asymptote?
Yeah.
What is it?
Zero.
Can't just say 0. Asymptotes are lines.
Y equals 0.
So I agree there's an asymptote. What's the asymptote?
X equals 0?
X equals 0.
Right.
It's the y-axis. A vertical asymptote. Vertical lines have the form x equals a number. Let's start there. Okay, we'll do that. Actually, no, I want to do 10. So I'll do base 10, the common base. Right? Remember, it said there were two commonly used bases. Base 10, the common base, which is the base that you're all familiar with, it's the decimal system. And then base E, the natural base. So I'm just going to look at base 10. It's the easiest one to look at. I'm going to stick with the green, which is the log base 10, not log over 10. From here you can see, obviously it's increasing, right? It's a very quick increase. And then the increase begins to decrease, right? Opposite of the exponential. The exponential started off slowly, but then exploded. This function is strictly increasing. Right? Believe it or not, this does keep going up. It's just very slow. If we wanted to get even up to y equals 10, we'd have to go all the way out to 10 to the 10th power on the x-axis, which is 10 billion, just to get y equals 10. Just to give you an idea of how slowly this is increasing. Right, 100 would give you 2, 1,000 would give you 3. But it is increasing. I already stated the domain, the range. X-intercept is 1, 0. And x equals 0 is the vertical asymptote. Right, and then I kind of went over these. Common logarithm, log base 10. We would just simply write log x, logx, so that implies base 10. Then you have the natural logarithm, base e. That will simply be written as ln x. Why am I missing this? This expression is what we call logarithmic form, obviously because it uses the logarithms. And this expression is what's known as exponential form. Of course, notice that they say the exact same thing. These two expressions are what we call logically equivalent. They have the same truth value, which means they say the exact same thing. Now, just as a quick note, in terms of speech, I typically refer to the natural log as just log. So if I'm saying log x, generally I'm meaning the natural logarithm. Yeah, because that's the one that we use all the time in math.
Which is the E one, right? So
Basic.
if you say like log x.
Log of x, I'm generally referring to ln. Right, you'll notice even, if I go back here, I had to specify the base in log. If I don't have that b there, I just put log and then x, it's the natural logarithm in Mathematica. If you want any other base, you have to actually specify what the base is. Write the expression in exponential form. What is the base?
2. And then the exponent would be 3 equals 8.
Okay, we'll do that.
You put it back.
Either y equals x. Doesn't matter.
Yeah, that's your
It's transitive. I was going to write 8 equals 2 cubed, but I'll stick with 2 cubed equals 8.
base is 8. The exponent negative 2/3 equals 1/4.
This one's easy to see. Is that a true statement?
Yeah.
2 cubed is definitely 8. Is that a true statement?
Yeah. But it's just part of it.
That one's also true. And again, since the statements are logically equivalent, that means log is also true.
Is there going to be like any that aren't true?
I may give them to you.
So you just have to like do the actual math.
No, if I just ask you to write an exponential form, just write an exponential form. That one's also easy to see. That one is clearly a true statement. What's our base?
B.
What's the exponent?
D.
Equals
C.
b to the d equals c. What's the base?
0. 100. Negative 1. 100. 1. 0.
You can't have base 0.
Infinity. There is no.
There's a base.
Log. 0.1.
Oh, E. It's E. It's 2.14. Isn't that E? 2.14.
2.72.
Is it 2.72? X. It's 10.
That's the common log. Base 10. It's the power.
Negative 2.
What does that equal?
1 over 100.
Again, that is a clearly true statement. This expression in exponential form, what is the base?
X.
The base would be log X.
E.
Base E. What is the exponent?
Y minus C. X. X2 plus 5x minus 6.
Wait, so before it didn't say write the expression blah 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 in exponential form, it said write it in natural form?
It's all been exponential form. All the changing of the bases, the powers, and what it equals. It's a little inside knowledge. This is a common practice in math. Let's assume that capital C is actually a constant. What is E raised to a constant?
Exponent? No.
So what's E raised to some number? Exponent is c. If you just raise e to a number, what do you get?
Another number.
A number. What's 1 over a number?
1 over a number. The number.
It's just a number. So we just write it like that. So a is some number. Just makes it simpler. It's a very common practice in math and science. Again, that's only assuming.
That's C is a quantity.
That c was a number. In this case, I'm restricting my numbers to real numbers. Now we're going the other way. We now want to write it back into logarithmic form. What's the base?
2.
3.
What are we going to be taking the log of?
243.
And that equals
5.
log base 3 of 243 equals 5. What's the base?
6.
What are we going to be taking the log of?
1 over 216.
And that equals
-3.
log base 6 of 1 over 216 is -3. What's the base?
256.
What do we take the log of?
64.
And that equals what?
94.
Log base 256 of 64 is 3/4. Is that true?
No.
That's your thing.
That is. Fourth root of 256. You don't need to calculate.
Wait, what? Oh, no, I was checking my calculator.
Fourth root of 256. 2 ways. One of the easiest ways to write 256 as a power of 2, so it's a power of 2.
256 times 4.
Fourth root of 256.
Oh, it's going to be 8.
It's 2 to the 8th power,
Wait, I would even guess.
which is 4 to the 4th power. So what's the fourth root of 256? 4. 4 cubed is
2.
4 cubed.
4 cubed. 4 times 4 times 4. 4 times 4, 16. 16 times 4.
Or you could do 4 is 2 squared. So 4 cubed would be 2 to the 6th power.
2 squared. 4 times 6.
Not times 6.
Oh, 4 times 4 times
All right, 4 to the 3rd power is the same as 2 to the 6th power. So it's 2 to the 6th.
64.
64. This is a true statement. It's the base.
1/2.
You take the log of,
30.
and that equals what's the base?
U.
Of what?
P.
Equals
M.
what's the base?
E. Log E.
Of what?
Y minus C.
Equals
8C plus B. Wait, hold on though. Can I write it down first though?
sadly, this cannot be simplified, even if C is a constant. Getting comfortable with switching between the two forms is kind of key to understanding logarithms. However, generally, you won't write it out. You'll just do the conversion in your head to solve the problem. These are ones we evaluate without the use of a calculator.
Oh, it would be like
So log base 7 of 49.
that would be, there's a 0 on the other side, basically, right?
Hmm?
So would it be like
There are two ways to approach this. Write it in exponential form,
would it be like
right? Because what we're really doing is saying y equals log base 7 of 49.
B equals 49?
So what's the base?
7.
What's the exponent?
0.
7.
A.
E.
1.
Nah, because there's no number on the other side though. It would be 0. Log 7, 49. The whole thing?
That's the expression I'm looking at. So what's the exponent?
Oh, y.
And what does that equal?
49.
7 to what power is 49?
3. 2.
2. We just said y is log base 7 of 49. The other way is just to do this. Recognize right away that 49 is 7 squared. So it's log base 7 of 7 squared, which is 2. Log base 4 of 256. Again, it's implied. You write it as y equals log base 4 of 256. If you're writing an exponential form. Base is 4, what's the exponent?
Y.
Right, so the question is 4 to what power is 256?
6. Can I use my calculator?
You don't need it.
Oh, didn't we already do this? Wasn't it like 8? Or 4?
It's 4. Eight was for 2. You want to write both sides as powers of 2. All right, you could write it that way. You could do 2 to the 2y is equal to 256, and 256 is 2 to the 8.
So which way would we write it? Like if we were to answer it, would we just put y equals 4, or would we put that whole thing at the bottom, like log 4, 256 equals 4?
That's what you're looking for. If you wanted to put y equals, you'd have to include that statement up there. Then you can say y equals 4. What's the base?
E, ln, log.
10.
What's the power of 10?
Negative 1, 2, 3, 4, 5. Negative 5. Negative 4.
You're off by 1. What's a negative 5? It's not
Negative 6.
It's negative 6.
Oh, because it takes away that 1 right there, right?
Here's what you're supposed to do.
Wait, would that
Take that decimal place and you have to count how many places to the right are you moving it.
would that like the logs, would that
6 places, so it's 10 to the minus 6.
But wouldn't that log thing be under it?
What do you mean?
Like, wouldn't it be under?
Would what be under?
Oh, wait, actually, yeah. Wouldn't that be under, like the 0.0000?
What do you mean by under?
Like, shouldn't it be under it, not the like in front of it? Like how the other one was like log 4, it was under it. No, not that's not what I mean. Under, like I'm under exponent.
Subscript?
I don't know what that means, but like that, yeah.
That's a subscript.
Shouldn't it be like that?
Because it's not base 0.000001. It's base 10, isn't it? There's a 10 implied to be there. We just don't write it because it's the common log.
But you wouldn't be wrong if you accidentally
What's the base?
27.
So 27 to what power is 1/9?
-4.
27, -4. 2.
27 squared is going to be larger than 27. All the negative does is flip it.
E. -E.
So if you need to, write it as powers of 3. What's 27 as a power of 3? It's 3 cubed.
And 9 is 3 times 3 is 3 squared.
Now use your laws of exponents. Solve for y. 3y is -2, so what's y?
You could use the same thing.
Now you have the same base, your exponents have to be equal.
Yeah, but you just basically did what we did up there.
Hmm?
Right.
Well, I wrote what's up there in exponential form, so we could solve for y.
Oh,
So what's y?
2. Negative. Oh wait, no, you just did what? -2/3.
Log base 27 of 1/9 is -2/3.
That would have been easy with a calculator, right?
If you know your powers of 3, you can solve that a lot quicker than it takes to type it into the calculator. All of these problems are implying no calculator.
That'd be -1/5.
Is the base?
Yeah. And that would be 5.
So I'll write it this way, 5
over 1.
to the negative y equals 125 is a power of 5.
And we have a 5.
What's 5 times 5?
125.
5 times 5
Oh shit, 25.
times 5.
125.
How many 5s were there?
10.
3. 5 cubed. So what's y?
5. Oh.
Same base, so your exponents have to be equal. So what's y? What is it?
-3.
depending on the calculator you have, you only have two bases, 10 and e. Not every calculator has the option to do any base. If you're one of those who doesn't have that option, then you're not going to use your calculator for these. The Inspire definitely has the option. Why do I not have a mouse? Why do I not have a cursor? That's concerning. There you are. Thank you. So obviously we just have ln there. That's obvious. So I have log here. And on the TI Inspire, if I click log, it's going to give me an option for a base. I can just leave it blank, I believe, and it should just assume base 10. It does. If I want the base, I just put in the base, and then I'll plug. And if you're not that lucky, then you're not going to be able to use your calculator for those. Not yet, anyway. There is a way to do it, but we don't study that till Wednesday. I think the TI 83 and 84 does have it. You just have to search through the catalog to find it, which is very time consuming if you don't know where it is. Again, by the time you even find it, you probably have solved 3 or 4 of them. So let's go back to that list of rules for domain that we started at the very beginning of the semester. Right? We only had 2 rules at the start.
Oh, it's like you can't have like a negative in the denominator, right?
Now let's divide by 0.
Can't have a negative.
If you have an even radical, even indexed radical, what you're taking the radical of has to be non-negative. Those are the tools we had so far. We can now add a third. Where you take the log of has to be greater than 0, regardless of your base. So find the domain. Remember, whatever we take the log of has to be greater than 0. We have a log. We're taking the log of x plus 4. Which means x plus 4 has to be greater than 0. So x is larger than negative 4. And your domain would be negative 4 to infinity, closed at open at negative 4.
X gotta be greater than negative 4.
Because remember, what you take the log of has to be greater than 0, has to be positive.
It could be 0.
Can't be 0.
Or it would be greater.
If it was 0, the question would be, so log, let's say log base 3 of 0. 3 to what power is 0? That's what that would say. And there is no power. You cannot find a power that, when you raise 3 to it, gives you 0.
0?
3 to 0 is 1.
If it's 0 is 1.
So it's undefined. No such power exists. No such finite power exists, let's say that.
So we would be looking at 2x plus 9.
What about 2x plus 9?
We would set as being greater than 0. Which means x gotta be divided. X gotta be greater than negative 9 over 2.
So your domain would be negative 9 halves to infinity, open.
So it's whatever is in the parentheses.
Whatever you're taking the log of.
ever will the -2 at the end ever interfere with it?
No, that doesn't. That's just a transformation, right?
So it would be 12x, or 12 minus 3x is greater than 0. So x got to be greater than 4.
4 is greater than x. Oh, because you have to flip the sign. Oh, I solved it that way. If you do it the other way, you wind up with this.
okay, that's why I did the other way. I did plus or minus 12, then divided by. So you have to flip the sign, right?
When you multiply by a negative, you have to flip the sign.
All right.
Remember, division and multiplication are the same thing.
So it would be 3 minus x is greater than 0. Plus x. 3 is greater than.
So the domain, negative infinity to 3 open.
Negative x is greater than 3, or greater than 0.
This one's pretty easy.
So it would be negative infinity to infinity.
Negative x is larger than 0, so x has to be less than 0. Move that here.
But it's plus
X plus 2 is greater than 0.
So 5x would be larger than negative 10, right? And so x is larger than negative 2. So domain would be -2 to infinity open. They are really boring problems. Let's see if AI can come up with better examples.
AI.
Oh, thank you so much. AI, when used the right way, is a wonderful thing. Oh, yes. So, this one. Find the domain.
X squared minus 4 is greater than 0, and then you subtract where you add 4 to both sides. So x is greater than 2.
No. I know what you did. You evaluated it wrong.
X is greater than, or x is, what's it called? Plus or minus 2?
So you can't write it that way.
Plus or minus 2?
Absolute value of x is larger than 2. Square root of x squared is absolute value of x.
Square root of x is absolute value. But you still need a square root of the other side for the 2 and the fine.
Yeah.
So what?
Because by definition, the square root is always the positive root. But we don't know if x is positive or negative. Right, so again, if x is negative 2, what's root 4? Positive 2, right? That's not x, because we said x was negative 2. But now you need to use the interpretation of that.
So how would you write the domain? Or we could write that.
So this piece here is the interpretation of absolute value of x greater than 2. These say the exact same thing.
Yeah.
And I think I had a slide earlier in the semester when we were covering domains that went over this, that went over those interpretations. So you have to go back to that slide or review algebra, because that should be covering algebra. But that's the interpretation. Now write an interval notation.
Negative infinity.
That's your domain.
Quadratic.
Oh, just you wait. These are just the moderate difficulty examples that ChatGPT gave me. I saw the challenging ones that were really interesting.
Oh, interesting.
I can't wait to get to them. Still not as interesting as I was hoping, bro. I was hoping to get a mixture of things like square root of a logarithm in the denominator or something like that. Like really mix it up, but they didn't. That's okay. These are just as fun.
You could just put like make them harder. And then
I could, and depending on how much time I have, I might go in there and adjust the prompt and go, now come up with examples that mix square roots and fractions. Oh, GPT is a beautiful thing. And beautiful reference that I've been reading, Teaching with AI. Gives some nice examples on how I can incorporate it. Keep up with the technology. How are we going to approach this?
AC method.
Well, first,
You have to do 4x squared plus 4x minus 15 is greater than 0.
then what we have to do is we have to find, remember when you solve a quadratic inequality, or generally speaking any inequality, linears are easy. You need to find breakpoints first. That's where you set the quadratic equal to 0. Right, which is where you were heading with the ABC method. But before that, look to see if that can be factored.
It can't. Unless.
Yes, okay. Factors of 15, 3 and 5. Factors of 4, 2 and 2. 2 times 3 is 6, 2 times 5 is 10, 10 minus 6 is 4. This can be factored. You can still use quadratic formula, that's fine. And higher has to take the plus.
15 or 5.
So it should factor that way. And that's obviously 4x squared minus 6x plus 10x is plus 4x and minus 15. Done. And then from here,
We have to do this.
you should easily see that you get either -5 halves or 3 halves as your zeros. There's the breakpoints, so now you have to set up your test intervals. Pick a test number in each test interval. Which I'm going to write below it. And determine the sign of the quadratic in each one. For each one. -10, that's negative, negative times negative is positive. So sign in that interval is positive.
Wait, how do you do that again? You
I plug it into the factored form. So I'm taking -10. That's -20, plus 5 is negative. Clearly this is going to be negative. A negative minus something is negative. So then it's negative times negative is positive. I don't care what the value is, I just care is it positive or negative. Right, which is again why you can choose such large outlandish numbers to make it really easy. 0 is easy, always use 0 when you can. Positive times negative is negative. Then you get +10, positive clearly. 20 minus 3 is positive, positive times positive is positive. Now you look back at the original inequality. What was it? Yes, but what was the inequality itself? What was the symbol? What kind of inequality are we dealing with?
Greater.
Greater than, so you take the positive values. Is it greater than or equal to? So can it equal 0?
No.
So endpoints are not included. Breakpoints are not included. So there you go.
So since it can't equal 0,
The breakpoints are not included. They're open. Right. Remember back to the second day when we were doing domains, we had or equals for the square roots, in which case the breakpoints were included.
So how would this look if we were gonna include it?
It would just be closed instead of open. Breakpoints would be closed. This one's kind of easy too. Oops, that's better. We don't do that. Base. Oops. Slide now. So domain Again, this one's fairly easy.
It'll be 1 minus x squared equals, or is greater than 0, and then it would be what? It would be the absolute value of like -1.
So I'm going to do this.
Negative.
I'm actually going to keep the x squared on the left-hand side this time, just to make it easier. So subtract 1 from both sides. Multiply both sides by -1. Flips the sign, right? Flips the inequality. X squared is less than 1.
So it would be the absolute value of x is less than 1.
Is less than 1. And that interpretation is this. -1 less than x less than 1. Now just write an interval notation. Open interval -1 to 1. I love how it gave me more of the challenging examples too. Though I would argue this one's not really challenging.
X cubed minus x is greater than 0.
So here we're going to have to find breakpoints. Fully factor it. You should easily see that that is its factored form. X times x plus 1 times x minus 1. Which should easily give you the zeros. -1, 0, positive 1. None of them include 0. Let's go -10, -1/2, +1/2, and 10. Right, those points are just arbitrarily chosen, right? You just arbitrarily pick a point in your interval to use as your test point. -10. Negative times negative times negative. Negative.
And then the same thing.
-1/2.
Same thing.
Negative times positive times negative. Right? -1/2 plus 1 is positive. That's positive. 1/2. Positive, positive, negative. Right? 1/2 minus 1 is negative. So 2 positives and a negative is negative. And then 10, this one's really easy. Positive, positive, positive. So that's positive. What is our inequality? And again, we're dealing with logs, so it's easy. It's greater. So you take the positive values, breakpoints is not included.
So we're not going to include the -1/2 or 10.
Oh, those are the test points. The break points are not included.
Or I meant the -1.
Yeah.
0. Only the positive ones you just put down.
We just want the positive ones, right? Because the intervals that are negative would make the function less than 0. The positive ones mean the function is greater than 0. Oh yes, now we get to the fun ones.
Yeah, that would just be.
So how would you find the name?
Do x plus 2 over x minus 3 is greater than 0, and then you find the breakpoint.
Yeah, so
and then
the process is the same. It's just now how we go about it that's going to be different because it's rational.
Would the breakpoint be like x plus 3?
So breakpoints are anywhere the function is 0 or undefined.
X minus 3.
This is a real simple rational function to work with.
Yeah.
It would be 0 whenever the numerator is 0. I mean, that's always true. Right? Rational function is 0 when the numerator is 0, undefined when the denominator is 0. X plus 2 equals 0, well, that's linear, that's easy to see. So you get x equals -2 as a breakpoint. Where is it undefined? When x minus 3 is 0, which means x is 3.
So the numerator, which is up top, the numerator
Numerator is the top.
It has to be 0, and then the bottom, the denominator has to equal 0 as well.
Yeah, to be a break. So technically, I think what they use is breakpoints where the numerator is 0 and exclusion points when the denominator is 0. All right, so technically speaking, we have one breakpoint and one exclusion point. I just call them all breakpoints. And they do distinguish because the exclusion points can never be included, regardless of the inequality.
And now I have to do the test stuff.
Right, so what I'll do is I'll just underline the exclusion point. Right, because let's say this was greater than or equal to 0. You would include -2 in your interval, but you would not include 3. Because x can't be 3, otherwise the function is undefined. Right, so that's why there's a distinction. Here it doesn't matter because it's just simply greater than, so we're not going to include endpoints regardless.
Yeah.
Now we do the same process, right? Set up our interval, our test intervals. This is why I just call them all breakpoints, because you're still breaking up the real number line at those points. Pick a test point from each one. Oh, look, 0 is included in that middle one. That's nice. And now test the sign of the function. -10. -10 plus 2 is negative. -10 minus 3 is negative. What's negative divided by negative? 0, you get positive divided by negative, which is what?
Wait, so that would be Oh, that would be negative.
And then at 10, you get positive divided by positive. What was the inequality?
Greater than.
So we take the positive intervals, endpoints not included.
Okay, so it'd be negative infinity, comma, negative 2 at u, 3, comma, infinity.
Just for mathematical terminology, that's not a U.
Oh, I mean,
It's a cup.
a gap.
It's a cup.
A cup.
Yeah. This symbol, go away, pop up. This symbol is a cup, the union symbol. Honestly, I don't know why they use cup in the LaTeX coding instead of just union. No idea. But it's a cup. Right, so that's how you would solve a rational inequality. And again, same process regardless of the degrees of the numerator and denominator. It's just a matter of how you find your breakpoints.
So would everything on the bottom in a rational equation?
So all the zeros of the denominator are what are called exclusion points.
So
You're still breaking up your real number lines at those points, but you never include them in the intervals in the domain.
So if that was greater than or equal to the 3 infinity would not
Yeah,
be
so
there.
let's say this was or equal to.
That would not be the 3 infinity.
That would be closed there,
Yeah.
but the 3 would still be open because it's an exclusion point,
Oh, okay.
right? That's why there's the distinction. That's why I just underlined it
All right.
to signify we're never going to include it. Again, all that should have been covered in algebra. I say should have been. Doesn't mean it is.
Yeah.
And this is why Precalculus should be a 2-semester course. My other school actually finally made it 2 semesters.
Really?
Yep.
Roman?
No, Brown College of Burlington County. Finally made a Precalculus A and B for 2 semesters. Because then you can delve into solving inequalities in Precalculus. Then you actually have time to do it. But what do I know? I just teach it. I'm not paid high enough to be an administrator. They make more money than me, so they're smarter. Yeah, that was really interesting ones. How would we solve this?
You would do, that's called log, right? The ln.
Yeah, natural log.
So the natural log of x is greater than 0.
Yeah, greater than 0. So this is going to require some knowledge of the natural log graph.
That's the
But honestly, all the graphs are basically the same. Since I already have it, let's go to it real quick. Natural log base is what?
10. E.
Is E larger than 1 or smaller than 1?
Larger.
It's the green line. It's going to be similar to the green line. What do you notice? Where is that negative? Or they want positive. So where is that positive?
Past 1.
So that would mean x would have to be 1 to infinity for natural log of x to be positive. that's what that means. But we're not done. Natural log of x means that x has to be what? So both of these statements must be true. X has to be positive and greater than 1. So let's write that. If you were to write that out in integral notation, it would be the intersection of the two intervals. What is that intersection?
The intersection?
Mm-hmm. So what do they have in common?
Infinity.
Just infinity?
And 1.
It's just those two. Does 0 to infinity include 1 to infinity? That's your intersection. 1 to infinity. All right, so in this case, that x being greater than 0 was actually meaningless. It didn't add anything. But that's not always going to be the case, so you have to keep that part in mind. Or will it always be the case? It might always be the case. It would have to, yeah. It would have to always be the case because x would have to be larger than 1.
A logarithmic function,
It always intersects at the 1 x equals 1.
That's always the x-intercept. Well,
Yeah.
natural log of x. Log of x, which just x. Once you start to involve transformations, obviously then it's going to change. But always start with the x-intercept being 1 and then apply transformations as needed.
That would be log of x squared minus 1 is greater than 0.
So here's where then the transformation comes into play, but we can kind of get around that.
Because we already did it. So it'd just be
X squared, so whatever you take the log of would have to be larger than 1.
so
Well, again, I want to be careful. The base here was e again.
yeah.
Because that's greater than 1, that's why it has to be greater than 1. Right? If we go back real quick, if the base,
Was like 2, or no, I meant like 3 or something.
still same thing, it's larger than 1. If the base is less than
Negative.
1,
So it was like a fraction.
then it's the
The other
pink,
way.
it's the pink line. Right? In which case it's positive
So then it would
To
be
the left
the
of-
sign would be.
from 0 to 1, between 0 and 1.
Okay.
It would have to be. Right, but it's always going to be 1. Because that's the intercept.
So that would be the absolute value of 1. Or absolute is greater than 1. Oh, because you added.
X squared minus 1 is larger than 1. Bless you.
Thank you.
So absolute value of x is larger than root 2. Which would be this. Less than negative root 2 or greater than root 2. But x squared minus 1 also has to be larger than 0, right?
Yeah.
But we just said that x squared minus 1 had to be greater than 1, so it's already guaranteed. So I'm not even going to look at it. That would be our domain. And then don't forget, you also have to include your other two rules as well. So you may have a mixture of all of them. Right? Could be like something like the square root of the log of that. You have to mix in your all of them. Well, natural log is easy. Natural log is always greater than 0 anyway, so that takes care of the square root part. It's already guaranteed to be greater than 0, so you can ignore it. Questions on logarithms? On Wednesday, we will examine the laws of logarithms. Right, so properties of logs, which are very similar to the laws of exponents. So we essentially look at the logarithmic analogs of the laws of exponents. Those are your laws of logs. After that, spring break. So we only have one meeting left before spring break.
So wait, after this week is spring break.
Next week's spring break. So then we get a week off. And then we come back and solve equations.
Is there going to be homework during spring break?
There is a spring break assignment, but it's a real easy one. It's meant to be more fun than anything. It'll just be applying AI and kind of seeing some of the pitfalls that may occur. All right, so you do have a homework due Wednesday. The homework on this stuff, I am not going to make due over spring break. Right, normally it'd be due next Monday, but next Monday spring break, so it'll be due the Monday after that. So you have 2 weeks to work on this homework. So you don't have to work on it over spring break.
All right. I'm gonna do. What's that?